Good morning students, welcome back to digital electronic class. In today's class we are going to take the revision of the questions of that unit 2, in which the questions which we got it, that questions I am going to discuss in today's class. So students, we are going to cover the questions which we do have for the unit 2. So in that, the first question for the LQ would be implement the half adder and subtractor using NAND gates. The question in this, they asked to solve the half adder and the subtractor using NAND gate. Okay, so for doing these things, we know that what is the sum actually for half adder? Sum is equals to a b bar plus a bar b. This we know it, right? So what we need to do? Instead of using the basic gates, we need to implement this particular function by using the NAND gate. In order to proceed with that, what actually thing we are going to do it? We'll take first A input and we'll take the B complement of it. B complement means we connect with one NAND gate, right? So this is a B complement. So this we need to pass to one more NAND gate. So till here, what is the answer of it? Till here it is B means it's nothing but B complement. So here A, B complement, whole complement. By applying De Morgan's, what I can do it? I can segregate this into two parts. I'll get A complement in plus B double complement. So it is nothing but A complement plus B, right? We have A complement plus B? No. So again you need to pass to one more NAND gate. You will get the desired answer of A, B complement. So by applying one more complement, you will get this thing. This is the first one. For the second part, what I can write? I can take A, or I can take the connection from this, or I am taking separating thing. I can do it like that also. So I do have A, and so better you just take from here. It's become, we do have already A is there, right? So it is nothing but A complement. So now next thing we need to take from B. So this is B, right? So this again we are passing to one NAND gate, another NAND gate. So we got it as A complement B. The next thing what you need to do it, we need to take this into addition form. For that, what you need to do, you need to take one NAND gate. So what I'll get here? A B complement into A complement B whole bar, right? So what I can write for this? I can segregate this is whole A and this is your B. So I can write it as A B complement, one more complement, plus A complement B, one more complement, right? So what I am getting? A B complement whole complement plus A complement B whole complement. So if I want to remove the complement in that, what I can write? I can remove this complement. I'll get A complement B plus AB complement. That is nothing but our desired sum function. So for that, what I am doing? Either you can stop here, or else what I can do it? You can segregate into two parts of it. That we can do it. So this is the thing we got it for sum. Next we know that carry also we had the function. So carry is nothing but carry is equals to AB, right? So when you had AB, you will get the carry. So we'll take A, we'll take B, we'll pass to two NAND gates, we'll get the answer as AB. This is your AB. Clear? This is the way you need to go for some adder and subtractor for using NAND gate. Next question, implement full adder with all necessary steps to design its logical functions. So we need to go for full adder. First thing is the block diagram, truth table of it, then sum carry by using the NAND gates. So here they did not mention NAND gates. It's for your practice, you can try it. You can go with basic gates also, you can go with NAND gate. Anyone, it's up to you. Because in the question itself they did not mention by using the basic gates or NAND gate. You can design by using any one of them. Next question, implement full subtractor with all necessary steps to design its logical functions. The same steps you need to follow, and here you need to design for full subtractor. In full subtractor, what is the thing we need to do it? We need to take A, B, C, these three inputs. We had these three inputs A, B and C. So we are designing full subtractor. So what is the full subtractor output? Borrow and difference. For borrow and difference, you need to write all the steps, how many gates you are required. You can go with basic gates or you can go for universal gates, NAND or NOR. It's up to you. Since in the question they did not mention a specific gate level designing, you need to go for it. Next is design 6:1 mux using 8:1 mux. So there they gave 16:1 multiplexer we are designing by using the 8:1 mux. So this is the question we do have. So that part we will see how to we design it. So in that, how many inputs we required for 16:1 mux? We required 0 to 15. That indicates it's our 16 inputs. Those 16 inputs we will take it and we'll try to design by using 8:1 multiplexer. So this questions also we similar thing we cover in the class. Since our revision class is this one, that's the reason I'm just proceeding with that overview of it. How do we do it? In detail we already covered in the previous classes of multiplexer and demultiplexer. So in that, what actually we are taking 8:1 multiplexer. So how do we take 8:1 multiplexer? We'll take one 8:1 multiplexer, another we can take it here 8:1 multiplexer. So what we will do it, we will get 8:1, right? Here is 8:1 mux, here 8:1 mux. How many inputs we do have from here? I0 to I7, whereas over here I8 to I15. How many select inputs is there for this? It's 3, right? So we are saying it's S0, S1 and S2. So this is your S0, S1, S2. There are 3 select inputs. What about the second one? How do we get this thing? Here also I am considering S0 is my select. S0, S2 and S3, right? Why I am taking S0? Because in 16:1 multiplexer, the values of A, B, C, D, these are our inputs value. In that, start from 0, 0, 0, 0 to last would be 1, 1, 1. In that, this A, this is my A input. This is my B, this is my C. Again, this is my A. Next I am saying B, then I am taking D. Right? You can take B, you can say C, no problem. But thing is, A I am selecting, A I am putting as my real input. It is deciding for that. What I am doing for A, first thing I am connecting with one NOT gate, because it's A complement, all starting till 0, from I0 to I7. For I8 to I15 it would be 1, 1, 1. So that's the reason we are just passing with this and we are connecting here. So this is the way you need to write all the steps, truth table, designing and this kind of thing. You need to proceed and you need to do for the logical part also if they mention in the question. So here in the question, constructed 16:1 multiplexer using 8:1 multiplexer. The next fifth question is f of a comma b comma c d implement using 8:1 mux. So this also we did. We took the truth table, they gave the values based upon the truth table. You need to take for 8:1. In that truth table first you do it. After getting the truth table, what I need to do it? I do have a truth table like this. What are the values I'll take? As per the given condition, what are the values I do have? That point I'm just going to take it. So in that, what are the values they gave you? They gave 1, 3, 4, 11, 12, 13, 14, 15. So these are my inputs value. So first thing, I'll take those inputs value. So we to take from 4 inputs value. So we'll make the 4 input per box. We already covered this thing. So A, B, C, D is there. Combination of that would be 0, 0, 0, 0, like 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Like this 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. Like start from 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0. Right? Then we'll take next values. What are the next values that we do have? Next, if you want to write 1, 0 is 1, 0, it's A, B, C, D. So 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, right? So in the question they gave summation of 1, 3, 4. So in the question, summation of 1, 3, 4, 11, 12, 13, 14, 15. 12, 13, 14 and 15, right? So these are the given values. So 1, so this is 1, this is high, this is your output. Next 3, this is high, this is 1. Next, what I'll do, I'll segregate into 2 parts, like this I'll segregate. 2 classes I'll take it. Right? We did it. Next thing, 4. 4 is here, it's also 1. Next, after 4, 11. So this is 8, 9, 10, 11. 11, 12, 13, 14 and 15. This is called logic 1. This is also logic 1. This is what, here 1 is there, D value is what? D. D is 1. For this I can write, it's nothing but D. Because D is 1. What about this one? There is nothing values. This means all are zeros. This is logic 0. This is also logic 0. This is what? 1. So what is that we can write? This is D is 0, right? That is nothing but D bar. Here D is 1. So it is D. This is what? D is 1. Again it is D. Remaining whatever not given, that we can put it 0, 0, 0, 0, 0, 0, 0. Right? So this is the way we got it. We segregate into 8.8 value of it, then we can proceed by designing with 8:1 multiplexer. In that, what I'll do it, I'll take all the inputs values of 8. So if I'm having this value I0, I1, I2, I3, I4, I5, I6 and I7. So this is my 8:1 mux. So the output of would be only single. We do have this thing. So now this is my I0, I1. So I0, I1 should have D. So this is D. I0 is there and I1 is there. This is I0, this is your I1, right? Next I2. I2 is D bar. So this, whatever the values I do have, I've connected with one NOT gate. This is my I2. Similarly, this is logic 0, I3. So I3 is logic 0. Next, I4 is also having the logic 0. So the same thing, I'll short circuit here. This is your I4. I5 is D. So I5, I'll connect from here. This thing, I'll take it. Then I6 is logic 1, I7 is logic 1. So logic 1 is given to I6 and I7, right? They are 3 select inputs. What are the select inputs? A, B, C. D is deciding. This D is considered to be the input which is going to decide. So this is the way we can do the question. Next, they ask in the 6th question, explain 3 to 8 line decoder. So first thing, for 3 to 8 line decoder, we had 3 inputs value. That 3 inputs value, we will take it and we just want to write the respective output for it. So to write this thing, what we will do, we will take how many inputs value? In the question they said we do have 3 values. So what are the 3 values I can write? What the question? Question is design 3 to 8 line decoder. For doing this thing, what I'll do it? I'll take 3 to 8. That means inputs are 3, output should be 8. So for decoder, these things we already discussed. How do we do it? 1, 2, 3, 4, 5, 6, 7, 8. Right? For decoder, this thing we'll make the truth table. We'll give the value inputs. A, B, C's are input like. So starting from D0 to D7, we'll make the truth table, all the values, and we will write down as per the given condition, and we will design the logical function. So that way you need to proceed for that given particular question. Next, construct 4:16 decoder using 3:8. So same thing, we did the same question which in the previous class, that same one. You can proceed in that. What as the question is 4:16. 4 into 16 means 4 inputs, 16 outputs. That you need to design by using 3:8 decoder. What is the difference of decoder and the demultiplexer is that here we do have select input, whereas in decoder encoder we don't have the concept of select input. Only the inputs value and the output value we need to consider. Then explain truth table of octal to binary encoder. So octal to binary encoder means 8 into 3. 8 into 3 encoder. The same question we covered in the class. For that, first is block diagram, truth table. As usual, we need to proceed with logical function by using the basic gates. And the next question, explain difference between multiplexer and demultiplexer. So what is a multiplexer? It's a combinational circuit which contain 2 power n inputs, n select inputs, and output is 1. Whereas demultiplexer is having single input, based upon the select input it is going to produce 2 power n number of output. Whereas select input depends upon n factor. And what is a multiplexer? Multiplexer is used to perform the multiple inputs functions in which it's going to take the values of select inputs, then it's going to produce the output of it. Whereas demultiplexer do the reverse operation, where we use actually multiplexer, where we do have a binary adders, binary subtractors, where we do have multiple inputs and we need to produce only single output, right? For that we can go with multiplexer. And demultiplexer we will use for in the communication system, where the signal has been passed to one particular thing which is in digital form, zeros and ones. That signal reaches to the destination point where it needs to be demodulated or it needs to be de-encrypted. For that particular thing it's going to be used. It is used in latches, flip-flops, these things it's going to work on it. Based upon that it is going to perform it. So this thing you learn difference of multiplexer and demultiplexer, both of them. At least write down 8 points each. Okay, if it is come in LAQ. If it is came in SAQ, you can write down any 4 points for difference of it. Implement the function. They gave one function, summation 1, 3, 4, 11, 12, 13, 14 and 15. The C question is there. You need to implement by using 4:1 multiplexer. So actually this is for 16. 16:1 we are implementing by using 4:1 multiplexer. That means we have to make 4 blocks. How do we make that particular blocks? This is 8, right? So this 8:1 I'm just modifying. into 4:1. So this first 4:1 is there. What I'll do it, I'll take 4 blocks. This is my 4:1. So having 2 selected inputs, again I take 4:1. Again I'll take one more 4:1 multiplexer. Again I'll take one more 4:1 multiplexer. So in starting way, what I'll give 4 inputs: I0, I1, I2, and I'll give I3. For next, I4 to I7. For next, I8, I9, I10, I11. Then for the next, I can give I12 to I15. This is the way I'll get 4. That 4 I need to again combine, right? Because we want to get single, we don't want to get multiple. So we do again 4. So that 4 and single I'll take 4:1. So this is my select inputs A, B, C, D. For example, output is 1 and we do have 2 select inputs. So this is the way this whole thing is 8:1 marks we are getting by taking the 4:1 multiplexer. By giving the specific values, what are the values they gave? Based upon that, you need to take the function. So this is the questions which is there in unit 2. Those are important questions, and the solution you need to do it. Some of the students have done it and they got some queries on that which already have cleared it. So those who didn't got it, just refer this video. It is going to help you for unit 2. In the previous class we discussed about unit 1, the questions which we gave it as an important question for solving. That question you need to refer for unit 1, SAQ and LAQ. Okay, so this is about the questions which we do covered and practicing part which we had done it. So this thing you need to learn it and make the usage of this particular video for solving the questions. Thank you. Have a good day.